Hey, what's up guys, my name is Cherno and welcome to episode 11 of the Serialization series. So we're going to be jumping into databases today and figuring out how we can actually bundle all of these arrays and objects together into some kind of larger system so that we can just shove that data into a file and then later recall it as necessary. So last time, we kind of finished off our objects and arrays and fields and everything was working pretty well. We also managed to print everything out into a file and see all the lovely stuff here. So that's great, okay? The last step here, before we get into like optimization or anything like that, is to create some kind of database that can hold multiple objects and multiple arrays, right? I mean, I did kind of say that like in terms of container types, we do kind of have all of these ones, right? Database is kind of the higher level one, right? Database is the one that holds them all. So the idea is right now we have like the perfect ability to actually send off objects, and we can actually send multiple objects into a stream of bytes. There's nothing preventing us from doing that. If I kind of copy and paste this and call this object 1 or something like that and call it literally object 1, and then I kind of just say object 1.getBytes stream, suddenly, you know, I'll have to adjust the stream here to make sure that I also have, that I also have enough size for, you know, the other object. But the idea is, you can see that I kind of can actually concatenate two objects together in a row and have them exist inside this byte stream. That's fine. That's not really an elegant way to do this, because first of all, it means you have to know how many objects are in here. Like, for example, if I wanted to then recall those objects, I could obviously just easily say that I know that there are 2 objects. I need the size of each of the objects, which I do have. So I could kind of rejoin them, but I don't know what's in the byte stream, especially if I'm kind of reading this from client side. So that's obviously a terrible way to do it, and it's not something that we really want to do. I just wanted to show you that it is in fact kind of possible right now. There's nothing stopping us from actually literally just appending all of these objects, arrays, fields, whatever, into one big blob of data. But that's not how we want to do it. We want to obviously be structured and organized and all that stuff. So the first thing we'll do is we'll make a class, and I'll call this RC database. Okay, we're going to kind of take inspiration from the RC object class. So we're going to grab pretty much, you know, for now I'll grab all of the fields, and we'll kind of just go through them and see what we can fix up. So container type, obviously database, right? Name length, it's going to have a name and a name length. That's kind of a given. And then it's going to have, instead of this field count that we've got here, we're actually going to have a count of objects, right? Now, the other thing we have to decide is whether or not we want to store arrays inside objects. I mean, I'm not sure if I touched on this last time. Oh no, okay, we are storing arrays inside objects. Yeah. All right, just wanted to make sure that that was in there. So really all we need is an object count. So we don't need any of this anymore, right? So we have RC object, objects, and then we have an object count. All right, let's calculate a size as well. So this will be 1, 2, okay, fine. The last thing that I really want to do though is make sure that we are actually storing a size. It's something that we should have been storing this whole time. I wanted to kind of add it as an optimization thing, but it's going to be much easier for us to actually store the size instead of having to read everything. So I think I'll stick this right over here. So private int size, okay? It's actually going to be a field that is legitimately in here now. And everything will get that eventually. But we'll start off with just database. So, we have, when we make the database, we really just give it a name. And then I'll come into object and I'll steal that set name thing. All right, so now we've basically got a name that we're setting. Set name, all right. And then I'll also steal Let's see. I mean, I guess we'll still add field. I don't like the size thing, but we'll still add field for now. Where are we? RC database. So add field becomes add object, RC object, object. So objects.add object, size is going to be object get size, and object count is going to just be the size of the objects. Okay, cool. So next up, I guess we'll steal these two as well. So we've got our get size and we've got our get bytes. And then we'll kind of start writing this stuff out. So we've got the name, and then the next thing that I do want to write out is the actual size. So this will be pointer write bytes. Let's see, what have we got here? So destination, pointer, and size. Okay, and we'll add this into we'll add this into every array and object and field probably as well. No, well, field doesn't need it, but object and array does. Okay, cool. So then we'll write out, we can get rid of one of these. We'll write out our object counts and objects. All right, cool. So there we go. We're getting all the bytes for everything. And everything looks pretty good right now. So the size, I just want to go through this and make sure that we're kind of at a correct size here. So the size will basically be equal to the 1 byte, the short, the name, which we don't know how big that is. Let's see how we dealt with that here. I think we did that in, actually no, I think set name does that. Yes, it does. Okay, good. So we don't need that. So we'll have the name count though, which is the name length, which is 2. We have the size itself, which we also have to include. We've got the object count, which is 2, and then we've got the amount of objects, which we kind of deal with later. So that's the size. That's what the size is going to be set to initially. We will also make sure that we have a similar thing in object. I think we've got 1 plus 2, right? 1 plus 2 plus the thing plus 2 again, and then plus 2. So we'll kind of stick in a plus 4 in here, just so that we are printing out that size. I'll move size to where it's going to be in the file structure. And then in get bytes, I'm just going to make sure that we write out the size just after the name. So size. All right, cool. There we go. So now we're writing out the size for RC object. And I guess the last thing that we should do is do the same thing for array. So where is size? I guess we get the size just by doing this. So let's not do that. The first thing we should do is fix up the name. So I'll probably just copy set name from here, since that is the more complete one. We will have just before we have the type, we'll have the size. I don't know why I'm making this private, but anyway. So we've got that set up, which is great. Let's make sure that this now returns size, and then I'll cut all of that and set it equal up here. Okay, so we don't need get data size anymore. We don't need name length. So we've got one for the byte, then 2 for the short, then the name, which will be set in set name, size, which is 4, then the type, and then the count, and then the actual data. So one of the things that we are missing here is the actual data. So we don't know how big that is yet. So when we actually do set the data, we can probably just do get data size, right? So we create one from this data. So I think what we'll do is, because the data is somewhat variable, I mean, we do, like the issue is that we could have, since all this is public, there's nothing to stop us from just being like, hey, array, I want to set the data equal to something else. Yeah, because the idea of serialization is really you don't want to change your array once you make it. Like when I make something like an RC array, I shouldn't be reassigning data. I shouldn't be changing that. It's fine for me to read it, but I don't necessarily want to be able to modify it, because that's not really how it's supposed to go, right? If you want a new one, you can just make a new array. However, that is possible for us to do here. So it's kind of up to you how you want to deal with this. You could basically leave the final piece of the puzzle, which is the the size. You could leave the actual length of this data array to whenever you retrieve size, and then you can just add it on, or whenever you write out the size, right? I could just write it along with the actual size, and that way I would have the most current thing. I'm going to say that I am actually going to enforce the fact that once you do make an RC array, that data is there. Yeah, it does not get modified. Because the idea isn't something like, let's just say that you have an array of random numbers, and then that for some reason is in like an entity. Yeah, when you create the entity, I'm not going to make an RC array straight away and then link it to that like array of data that I have, and then later that same RC array will be written out to a file or something. That's not the way that works, right? What happens is when I actually decide that, hey, I want to now write out to a file, that's when I create the RC array with the data I want to write out, and I write it out, right? It's not something that you create at object initialization. It's what you create when you actually serialize the data. And that's something that probably should be explained with comments and JavaDoc and whatever. But that's the way that works. So because of that, it's really important to make sure that when we do something like, so get data size, when we do actually do this, so we set the data here, and we return the array. I'm just thinking a good place for us probably is we might have something like an init method or something, which I'm going to, well, I'm not going to call it init because the only thing it's going to do is update size. So I'll say update size, right? And then what that will do is if we scroll up to the top here, we'll have a private void update size. That'll just simply say size plus equals get data size. Okay, that's really all I want to do. Again, I could, it is one line. I don't have to make a method out of it, but I will anyway. So update size. The other thing we need to make sure is that that it is obviously being called from a static instance. So I'll just do that. All right. So now we should have an up-to-date size. And then that size should get printed out. All right, awesome. So back in RC database, which is the focus of today's video, we now have a size, hopefully, that is actually correct, right? And again, we'll have to verify this because I'm not even sure if RC object properly does this. We do have size here, but in terms of this stuff, of course, that wouldn't really, I mean, we do actually we do append array size and stuff, and we are printing, and actually everything should be correct. So we'll double check this in our testing, but I think that we've got all the functionality we need here. Okay, cool. So where were we with databases? So we've got the database, we've got the name length, everything looks pretty good here. We've got our collection of objects that we can add, and that'll update everything. Size plus equals object get size, good. Everything looks pretty good to me. And we're actually printing out everything as well. So we should be more or less complete, okay? Now, again, we don't, like, optimization-wise, yes, it would be a great idea to have some kind of table that shows us, the index basically into this database of where each object is actually located. Because if I want an object called, I don't know, something like, entity, and this database happens to contain 1,000 objects, I'm going to have to loop through the whole thing, not through every not through every byte, but through every object to find where that entity actually is, right? Instead of that, I could just have a table that showed me the byte offset of the object, so I can just read that straight away, and that would be very, very fast. It would be much faster than the current system, but that's like an optimization thing that we will talk about later. Okay, so there we have it. There we have a hopefully fully working serialization system. Nothing to do with deserialization yet, but we should be able to serialize data out pretty well. So let's talk about how we can do this. What we have to do now is create an RC database. We'll call this our database. I'll call this something like, I'll just call this database. And one thing that I quickly wanted to mention as well is that we should probably have, let's say, I don't know if we do this anywhere, we should have a header, because this is like, we basically only contain one database per file. So what we should have is some kind of header that says something like RCDB or something, rain cloud database, that just kind of makes sure that that we're actually correct. Now this should be a byte array, of course. Okay, and that just kind of gives us, that's just there so that we know, oh hey, we're reading a rain cloud database file. Okay, it's almost like some kind of like an initial validation, right? Just so that we can be like, okay, we are indeed reading the right file. Someone hasn't dropped in a file that is in the incorrect format. Okay, very small header, of course. We only got 4 bytes here, but that is enough for us to really identify what's going on here. So we'll write bytes, destination pointer, and of course header being the bytes that we're going to write. Okay, cool. So we've got the database. We're going to also, I guess, create the array. We've got an array, we've got a field. We create an object called entity, and let's just add that to the database right now. So we'll say database.add object, object. And then, of course, here we'll use database.getSize and database.getBytes stream, and we'll write that into our test.rcd, RC database or RCDB file. So let's just run this, see if we don't crash. It doesn't look like we did. I'm going to quickly open hxd. I just want to quickly see if I can so I can open up the folder here. Okay, so now we've got the test.rcd file that I just opened up in this viewer. That's the new one. You can see that immediately we can see that we do indeed start with RCDB as our header, which is fantastic. Let's go through this and make sure it's all correct. And we'll do a few tests here just to make sure that we are done, because this is actually all we need to do for serialization, right? So the serialization series is kind of over after this, isn't it? The deserialization series will start next. But no, I'll probably keep it. I'll probably still call this serialization series. I'm not going to make a new series called deserialization. But anyway, this is like the last video, so it's kind of exciting. As long as this works, of course. So container type, database, that's 4. We know that because 4 is right over here. Then what do we have? Back to database. The name length, which is short, so it looks like the name is 8 characters long. And then we've got the actual name. Now, it doesn't look like we do though. Did we print out the size before the name or something? Because we do have, it looks like, an entire like ints worth of stuff. Let's just, I probably printed it out and then, yeah. So size, whoops, size should be after name. All right, so let's try that again. Print. All right, this is looking better. So there's that short, that's the name. Then we have the actual name, which we know is 8 characters. So here it is, database, 8 bytes. Then we have the, I guess the size gets printed out, which is this number here. And then we have the object count, which is a short. So it says that we've got 1 object. This is the size of the entire database, by the way, right? So this should actually be the file size in bytes, right? And I guess we can probably verify that as well. Let me just open up this thing in Windows Explorer so that I know where we are. All right, where are we? Workspace, serialization. All right, here we go. So test.rcd is actually quite a large file. It's 200,074 bytes, okay? So let's get a calculator up. I actually don't have one. Let's get a calculator up for reals, or actually a hex to decimal converter. Windows calculator has that. Unfortunately, my one isn't working right now because of Windows 10 lols. But anyway, there's the number we want to convert. So it looks like it's 30D8A. Let's convert that. And as you can see, we should get 200,074, right? And that is indeed, as we just saw, the file size, 200,074. All right, fantastic. So that just verifies that that is indeed working. Next up, we have the object count. Another thing you can do, by the way, is if you get this number here which says what your file size is, you can actually verify that that is indeed the size of the file that you have. Okay, this is especially useful for files. Typically in a network scenario, you might split up these kind of binary streams. Usually you will wait until you get all of them back though first. So for example, if we were sending this over TCP and we split this up into 10 packets or something, we would get the 10 packets first, reconstruct the data, and then we would take a look at this, and then this size, for example, could be used to verify that we did indeed get the packets. No one modified them, or at least they didn't modify the size, and everything looks pretty good. Now, another thing we could do in terms of security, if you're worried about someone modifying your file, obviously checking the size is one thing you can do, and it's a very quick and easy thing you can do just to make sure that you are still the same size, which means that no one's added or removed bytes. It certainly also means that you didn't lose half the file, right? Because you might have accidentally interrupted it while it was being written out, or the game crashed while it was writing, and then this way you can just verify that, hey, this is the correct file, this is what I expected. But if you're more concerned about security and people modifying your file, you could of course generate a hash of the file, and then you could compare that hash to, you know, running the hash through all these bytes and seeing if that matches whatever hash is actually in the format. Of course, people could still modify that to match the new one or whatever. Like that could be done technically, but yeah, just make sure you don't run the hash through the hash, because that's not going to work anyway, because you don't know the hash yet when you're on the initial test. Anyway, all that aside, that's the file size there, which is very useful for us. We know that we have one object, that's our object count. We then have the beginning of the objects, right? So we have one object and we know that it starts on this next byte. So let's go into RC object and see what we got here. So we got the container type of object, which is what the 3 is. And everything else actually we know is correct already because we looked at it last time. We've got the, where are we? RC object. Here we go. I got the name length, which is 6 characters. That's the name, and then we've got, you know, all that other stuff. You can see we've got integer, random numbers, whatever. So that's quite a big example because we've got all of that stuff here. We've got the entire random numbers thing, but let's try out another field, okay? And I just won't actually add the array this time. So we'll call this like position, right? And then I'll say we have 2 integers here maybe. We have x, the x position, so x pos, I'll say is like, let's make this, the reason I'm making these integers is so that we can actually read them. If I make it floats, it's going to be very difficult for us to read the memory. We'll have to convert it. So that's why I'm not bothering with that right now. Let's just say this is like 2. And then, so that's position x. And then position y, which will be y pos, we can maybe set to like 30 or 43. We'll add those 2 fields just to make sure that multiple fields work fine. Let's just make them shorts just for fun, just to mix up the file type. What's wrong with that? Really? Why do you not know that you're a short? Oh, I guess because it would be ambiguous. Anyway, we've got the shorts now, and we've added them, so we should be correct as long as we don't add that array, which we didn't. Let's run that. Oh, we got a crash. That's exciting. Why did we get a crash? I didn't add that array. No, I didn't. Okay, so this is good. So we've got how many fields? 3 fields. Oh no, hang on a minute. Oh, the object has 3 fields. Yeah, so we got 1 object, 3 fields. Good. So why did that crash? Let's see. Field count is 3. Good. That's good. Obviously it's an array index out of bounds, so we didn't allocate enough space. But why did we not allocate enough space? What's pointer up to 61, and the destination has a size of, which you could easily see, of 60. Okay, so 69 is this size. We are currently up to 61. I guess when we tried to write this, it increased to 70, and that's what made it crash. Okay, cool. So we know why it crashed. Which object were we up to? This is the bad thing about for each loops. I don't know where I'm up to. I guess I could read the object and see what we have here. Name is that, which, I mean, that's the first one, isn't it? Alright, so after an embarrassingly long time, I discovered that my size for my database was wrong because I added this header, but I didn't bother actually writing that size in, okay? So this can really be something like header.length because it's totally static and everything. But there we go. So that's fun. Don't forget to write that out. And if we run it now, yep, we can see we get no errors, which is correct. So that was, yeah, good times. Anyway, now that we've got a bit of a smaller thing that we can look at, it might be a lot easier to see. So we have the RCDB. We've got that's the header, right? Then we've got, so I guess it just worked for the other thing. That was odd, wasn't it? Because it did work for, or maybe I added this now. I'm not sure, because it did work for when I didn't have the fields. So that's weird. When I had the array, it totally worked. Spooky. Anyway, I don't know why that is. I'll have to investigate that. Maybe there's extra room in our array or something like that that I didn't see, but it looks pretty okay. Yeah. Very odd. All right. Anyway. So, then we've got 4, which means it's a database. Then we've got the size of the name, which is 8 bytes. Then we've got an integer or something. What is that even? Where are we? We've got the size. Yes, that's the file size in bytes. We know the file is 49 bytes. And then we've got the fact that this is a field of type 3, and the name is 6 characters. It's called entity, and it's set to 34. Well, not really 34, but 34 in wait, what is entity? Oh, it's an object. Okay, we've got object, and we've got the size of the object, so 34 bytes for the object. We know that we have 3 fields in it. The first thing is a field. Okay, so where was the object? Because I thought that was objects 3. Okay, 1, right? So this was 1 object, right? And that's the type. That was object. Okay, cool. So 1 object, the type is 7, which means it's a double. That's wrong. I must be looking at the wrong thing. Where's object? Oh, sorry. That's name length. Integer is the name. 4 is the type, which is integer. And then we have, what's next? We have 8, which is the actual integer. Then we have another field. It's the name is 4 characters, X position, and it's set to 2. And then we have, yeah, so it's set to 2, which is this here, right? What's that extra character there? I'm being very meticulous with my testing here. That's got to be the type, right? Which we set to short. So yes, 2. Okay, good. That's the value which we put in, which is here, 2. Then we have another one, 4 for the name. There's the name. There's the type. There's the data, which is this kind of plus sign, 2b, which is 43. And then we've got just 2 null characters. That does not seem right. Why do we have 2 null characters at the end? we shouldn't have any, I believe. Because as soon as that object ends, we're done. Oh, we have array count. Do we really put that after the fields? I guess we do. Okay, we've got a short for array count, which is the 2 bytes here that we see that are both 0, which means we have no arrays. All right, cool. So that is it. That is the end of basically the serialization series. We now have the ability to serialize any kind of data out. We have no idea how to read it yet. We're gonna begin that journey next episode. But thank you guys for watching, and I'll see you next time. If you enjoyed this video, please hit the like button and have a nice day. Goodbye.